Hello, geometry students. Mr. Zacek back here and better than ever with you as we start Unit 4. And Unit 4 is all about answering this big question of how do we prove things congruent. And so we're going to follow a process throughout this unit of defining something and then looking at different pathways to prove that. So let's start off by defining what congruent figures are. You're going to see that congruent figures have the same size and shape. So when two figures are congruent, you can slide, flip, or turn one so that it fits exactly on the other one. I'm going to give you a little more technical of a definition is for congruent figures, there is a series of transformations. So a transformation is a slide, a flip, a turn that maps one figure directly onto the other. And we will look at that much more in depth in later units, but I just want to introduce it to you. So a series of transformations that maps one figure directly onto another. If that happens, that means they're congruent. So they match up exactly, and we say that as they have the same shape and the same size. So one of the key elements to this as we begin here, one of the key understandings that we need to have is we need to have a good understanding of what does it mean, this idea of congruent corresponding parts. So it means they're matching sides and angles. So when naming congruent polygons, corresponding vertices always must be listed in the same order. So you'll notice here that in these two figures, if we took the left one and we said, okay, let's name that ABCD, just going kind of in a clockwise direction, what corresponds with A? And we would notice that E is what corresponds with A. That's the same. We would flip this one over to get it. And then what's going to correspond with B? Well, that would be F would correspond with B. And then what corresponds with C? Well, that would be G. And what corresponds with D? That would be H. So the order of these letters matters. Matters because it indicates the corresponding vertices. So that gets us, the vertices aren't the parts are the sides and angles, but the vertices have to correspond as well. A vertex is the point where two sides meet. So let's do the angles first. That's a little easier. So we say, okay, angle A, that's our first letter, that corresponds with angle E. So angle A and angle E are going to be congruent if the figures are congruent. Angle B, that's our second letter, is going to correspond with angle F. Then angle C, our third letter, is going to correspond with angle G. All right, and then angle D is going to correspond with angle H. So those are the corresponding angles. Now for the sides, I'm going to come back and I'm going to mark the sides. So our first side here, AB and FE or EF, those correspond, and then EH corresponds with AD, so those are congruent, and then GH and DC, those match up, and then BC and FG. And so we use the different number of tick marks to indicate those sides. So one tick mark and one tick mark, those sides are congruent. 2 and 2, those sides are congruent. So AB is congruent to FE. You want the segment bar on top because we're doing congruent. And then AD is congruent to EH. And then DC is congruent to GH. And then our last side there is BC is congruent to FG. So in regards to like when you see, for example, like where I did DC and GH congruent, you notice that like D corresponds to H, and so over here I put D and then I put H. When you name the segment itself, you can flip the order around. That's not as important as it is with the angles. Okay, so all of the sides, all of the corresponding sides are congruent. Okay, so when two figures, just kind of summarize this, are congruent, all their corresponding parts are congruent. So all of the matching sides, all the matching angles have to be congruent. That's what it means for that. Okay, now I'm gonna kind of jump past this page. I'm gonna jump into these examples, and then at the end we'll go back to that proof that we have there. Okay, so if HIJK is congruent to LMNO, what are the congruent corresponding parts? So this is our kind of our given, all right? We're given that this is true. What are the congruent corresponding parts? Well, we have angles that are going to be congruent, and we have sides that are going to be congruent. So for the angles, we can simply follow the order of the letters, H and L. Angle H is congruent to angle L. And you could mark those on the diagram, H and L. Angle I is congruent to angle M. And we would do two markings, I and M. Angle J is congruent to angle N. Okay, so J is 1, 2, 3 markings. 1, 2, 3. Gets a little hard with the fourth one, so I'm not going to mark it. I'll just say angle K is congruent to angle O. All right, let's grab a different color here for the sides. So HI, our first side, is going to be congruent to LM. All right, and then IJ, that side would be congruent to MN. Just looking at kind of the order of the letters. And then JK would be congruent to NO. Those are the last two letters. And then the last sides, 1, 2, 3, 4, 1, 2, 3, 4. And then once I have them kind of drawn on my diagram, a little easier for me to write them out. So we say HI is congruent to LM. That's one pair. JI is congruent to JI 2 markings NM. Then KJ would be congruent to what's got 3 markings over here, that's ON. And then our last side, which is HK, is congruent to OL. Okay, and again, for each of the segments, remember you can switch around those things. Okay, so now, and number 2, it says if those triangles are congruent, what are the congruent corresponding parts? You could do this without drawing a diagram, but I would recommend drawing a diagram. Just, you know, make some triangle, W, Y, S, and I'm going to try, you know, and draw something that looks exactly like it, M, K, V. So that terms of that order, now if we mark these things, okay, W and M, Y, sneeze, hang on, excuse me, Y and K are congruent, and then S and V, 1, 2, 3. Okay, so now sometimes if all you're given is those angle markings from the sides, you see the 1 and the 2. The 1 and the 2, those sides are going to be congruent. The 2 markings and the 3 markings, those sides would be congruent, and then the remaining sides would be, that would be our last side. So let's go ahead and list all of these congruent parts. So we would have angle W congruent to angle M, angle Y congruent to angle K, angle S congruent to angle V. And again, you can do this without drawing the picture. I just think it's a lot easier when you see a picture, and that's a skill we want to build. So side WY and MK, and then side SY would be congruent to side VK, and then the last one would be WS congruent to MV. So there are 6 corresponding parts. All right, so 6 corresponding parts in a triangle. You got 3 sides, and we have 3 angles. Okay. All right, so then suppose triangle WSY. So let's kind of draw something again like this: WYS and MKV. So it says W is 62 and Y is 35. What is the measure of angle V? Well, we know that W and M are going to be congruent. And we know that S and V are going to be congruent. So really, if we could find the measure of angle S, we would know the measure of angle V. So the measure of angle S plus 62 plus 35 equals 180. Okay, and that is the triangle angle sum theorem. We know they all add up to 180. So the measure of angle S, that was going to be what, 97 plus 97 equals 180. So the measure of angle S equals, if we subtract 97 from that, what's that give us? 83. Okay, so 83. And then we know that the measure of angle S equals the measure of angle V, because the triangles are congruent. So their corresponding parts are congruent. Corresponding parts are congruent. And S and V are those corresponding parts. So therefore 83 equals the measure of angle V. All right. So we have just, different ways we can use it. All right, now are the triangles congruent? Justify your answer. So what we need when we're trying to prove this, congruent means we're looking for all 6 corresponding parts congruent. So that's the question. Are all 6 corresponding parts congruent? Well, what you want to see here is, let's add in our freebie. So our freebie is that vertical angles are congruent. If 2 lines intersect, then they form congruent vertical angles. So what we could say is that triangle ABC, now notice this is called a congruent statement. Triangle ABC, what side corresponds with A? Well, that would be E. Okay, so E, and then B, what corresponds with B? That would be D. See the 2 angle markings and the 2 angle markings. All right, and then C. So triangle ABC is congruent to triangle EDC because all 6 corresponding parts are congruent. Okay, all the angles are and all the sides are. Now we could get more into detail about measure and congruence, and at this point we're just trying to get the kind of the big idea here of this. Okay, so before we do this one, I'm going to jump back now to the third angles theorem because I think we're going to need it. when we get there. So it says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So in this picture, if A is congruent to D and B is congruent to C, then the other angles have to be congruent also. So for example, if angle A is 50 and angle D is 50 and angle E is 60, now this is not drawn to scale, I'm just making numbers up, then you know that if they all add up to 180, that the last angle would have to be 70. All right, that's what we're saying here. If we know two of the angles are the same, then the third one would have to be the same. And I've gone ahead and done this kind of proof out for you, and I just want to talk through it with you. So we're given that angle A is congruent to angle D and angle B is congruent to angle E. All right, that's a given. So the next thing I'm going to do is just convert them to measure. The measure of angle A equals the measure of angle D, the measure of angle B equals the measure of angle E. Why can we say that? Well, angles that are congruent have the same measure. Now we know from before the triangle angle sum theorem says that all the angles add up to 180. So A plus B plus C equals 180, D plus E plus F equals 180. The sum of the interior angles of a triangle is 180 degrees. Now, since they both equal 180, we can set these two things equal to each other. And that's what I've done in the next step. All right, write small. Measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D plus the measure of angle E. Okay, now, here's what I'm doing. With D and E, I'm going to substitute in for those A and B. And so that's what you see down here in this next step. Take the highlighter here. Now we're replacing those with the measure of angle A and the measure of angle B. Okay, again, substitution property. Now, if we go ahead and we subtract from both sides the measure of angle A, what's going to happen there is those ones are going to cancel out. Measure of angle B, those are going to cancel out, and we're just left with the measure of angle C equals the measure of angle F. So that's the subtraction property of equality, and then angles that are congruent have equal measure. Okay, so we can use this now. This theorem then becomes a reason we can use in other proofs, that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Okay, so let's jump ahead to this one. Whoops, go back. And this will be our, kind of last question for the day. All right. Is triangle, well, we got two questions. Is triangle ABD congruent to triangle CBD? Justify your answer. Well, the reality here is we cannot prove the two triangles are congruent because we cannot show that all 6 corresponding parts are congruent. So they might be congruent. They look like they're congruent is not a reason that we can give to prove, right? Just because they look the same doesn't mean that they are the same here. So we could, they do share a side, so we have two sides, but we don't know anything about the angles, and so therefore we can't prove that. All right, so our last one is we are going to be able to prove, and it's given that LM is congruent to LO, so let's mark that, and then MN is congruent to ON. Okay, now here's what we get for free. So that's a freebie, is we're going to be able to say that LM is congruent to LM by the reflexive property. We'll write that out in the proof, but I just want to kind of highlight that to you. That when you have those two sides there that are shared or in common, we can get that for free, just like we could with vertical angles. So then the last part is we've got M congruent to O, and then we've got MLN, that's this angle, congruent to this angle. And what did we just show with our other reason is that if two angles of a triangle are congruent, then the third angles are also congruent. So that'll get us our last angle. Okay, I'm going to go ahead and write all this out for you. We're going to start, obviously here a lot of this is given to us. LM is congruent to LO. MN is congruent to ON. Angle M is congruent to angle O, and angle MLN is congruent to angle OLN. Okay, and that's given. All right, so what we have here, now this isn't really a part of a proof, but it can just help you. You've got a side congruent to a side congruent to a side, an angle congruent to an angle congruent to an angle. So of the 6 parts that we need, so far we've got 4 of them. We've got 2 sides and we've got 2 angles, so we need to get 2 more. And here's how we do it. The side is our reflexive property. So LM is congruent to LM, and that is the reflexive property. That's a freebie. Okay, what did we just accomplish with that? Well, we got another side congruent to a side. And then we need to get that last angle. So the last angle pair would be angle MNL congruent to angle ONL. Why are those congruent? Well, that's the theorem we just said. If 2 angles of a triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So then the third pair of angles are also congruent. All right, what did we accomplish with that statement? Well, we've got an angle congruent to an angle. So now that we have made statements where we've shown all sides are congruent, all 3 sides and all 3 angles, we can say the thing we're trying to prove, which is triangle LMN congruent to triangle LON. And the reason for this is if all the corresponding parts of 2 triangles are congruent, then the triangles are congruent. All right. So that's what it means to be congruent. All right. That all of their parts are congruent. And so we can do some proofs to demonstrate that and give a reason for that. All right, so a little bit longer lesson. All right, good luck on your assignment. Let's keep asking questions.